everyone. In this video, we are discussing about the application of clustering algorithms, especially k-means and k-medoids algorithms for hotel customers dataset. What we are discussing here are what is the identified problem for the dataset we choose, about the dataset we selected, how we prepare our dataset for the algorithms, why we choose unsupervised learning and especially k-means and k-medoids, and analysis, discussion, and further result comparison. As we choose a dataset related to the hotel sector, for this domain, it is very important to identify customer segments and RFM values to revenue optimization, marketing campaigns, operational planning, long-term strategy kind of things. Our approach is to get insights using clusters for these strategies. The dataset we choose is from Kaggle and it is a real-world dataset collected from a hotel in Lisbon in the time frame of 2015 to 2018. It has 31 parameters and more than 83,000 instances. This data included numerical, categorical, and Boolean data as well.
In this section, we will talk about data preprocessing. We will talk about how we handle missing values, outlier detection, dimension reduction, also encoding features. We have identified some negative values in the age columns and also null values. We have removed those from the dataset. When analyzing, we have found outliers more than 120 above 120 age records in the dataset, which is very unlikely. So we have removed those outlier values as well. For example, we also had average lead time negative values for that column. We have removed those values as well, and also you can see a huge spike in the 0th value, which means people who booked on the same day have enrolled into the system and made the reservation at the same day. So also there were people who has booked 365 days before they check into the hotel. So those kind of scenarios are also possible because there can be events pre-planned. So we had an assumption and we decided to keep those values in the dataset. We have dropped all the placeholders and uncompleted bookings and name hashes, doc ID hashes, because those were not adding any value to the current problem or our dataset for further analysis.
Moving into the dimension reduction, we have applied principal component analysis. As we have 31 variables, there are 12 Boolean variables as well. Those are like special records for cribs, quiet places, bathtubs, kind of things. So we try to keep 95% of variance in the data and try to reduce the shape. But unfortunately, we couldn't reduce the shape from 12 and we have to exclude principal component application from our pre-processing step. Moreover, we have applied encoding and scaling. We have some categorical columns like nationality, market segment, and distribution channel where we have applied label encoding, and for the numerical columns, we have applied standard scaling.
Our intention from this dataset to find what are the behavior patterns of these customers for marketing purposes and campaign purposes. So we decided to go with unsupervised learning. We decided to test it with the k-means algorithm as a starting point because it is much faster with larger data sets. From that base, we decided to explore other algorithms.
As this is a real-world dataset of a hotel in Lisbon, we expect more outliers. Since we cannot reduce all outliers which is impacting to the nature of the data set, we considered having more outliers and we decide k-medoid would be more suitable, which is not sensitive for the outliers as well. And also we have some categorical data as well, which will be good with the k-medoids algorithm. Initially, to identify the optimal K value, elbow method is applied to the both algorithms. As you can see here, K equal to gives us the proper elbow turn. Furthermore, Celotes score is also plotted with the elbow value to identify the highest score. K equal to gives us the optimal value from these two matrices. The outcome of the algorithm shows almost same output with two clusters and almost same Celotes scores as well. Looking into the T-SNE visualization for both algorithms, we can see that K-means and K-midpoints identify the clusters in the same manner with the clear separation. Below is how market segment and distribution channel shows in different clusters for both algorithms. The interpretation of midpoints and centroids are shown in a heat map here. Overall, Cluster 1 shows short staying people with lower lead time in bookings, while Cluster 0 shows longer staying early booking customers who impact more in revenue. There is a high internal cohesion and clear separation for these two clusters. These matrices like Celotes score and Davis-Baldwin score confirms these identical behavior of the cluster separation. Even though K-midpoints are slightly more robust for the outliers, there is no significant difference between two algorithm outputs for this dataset. But K-means is preferred due to the efficiency as K-midpoints take much more time with this kind of data amount. Moving into the critical analysis, we have to note that there are some limitations with outliers and domain-specific data as well. And we can apply better dimension reduction techniques or improved algorithms like K-prototype for accuracies. And we can enhance this using business related metrics for our data. And also we can create some customer segmentation dashboards, which we can use to identify the behavior of the custom clusters over the time. We have applied DB-scan as well. You can see DB-scan with the T-SNE visualization. This is a merged version of DB-scan clusters. You can see there are 30 clusters with a high dimension amount of data. When it comes to apply RFM for this dataset, we have identified which variables are highly impacting to the data and what we need to do for the get insights from this data. As we are solving problems in hotel management, these insights directly support revenue management, optimization, frequent guest lead time patterns, and outlier detections. These are very important for marketing strategies, seasonal demand in forecastings, and other campaign strategies, ensuring that the clustering outcomes translate into measurable business impact. Thank you.